Hey guys, in this lesson we would understand the applications of quadratic equations when they are given in the form of word problems in standard form. Let's understand this with the example. And let's read the question first. In a volleyball match, Jenny serves the volleyball at 14 meters per second from a height of 2.5 meters above the ground. The height of the ball in flight can be estimated using the equation h equal to 4.9 t square plus 14t plus 2.5, where h is the height in meters and t is the time in seconds after she serves the ball. What is the maximum height of the volleyball above the court? When does this occur? Always remember, when the question wants us to find out max or min, then the best way to find out the answer is to turn the standard form to vertex form. And that we can do is by completing the square. So as the question wants us to find the maximum height here, we would turn this equation into vertex form by completing the square. And let's see how to do that. We are given this equation. We know the steps for completing the square, so we would follow all the steps. First, we have to factor a out of x squared plus bx. We would be left inside the bracket with t squared minus 2.86t plus 2.5 stays outside. The next thing we have to do is to divide 2.86 with 2. This is the b value. And we would get 1.43 with that. Then we have to square 1.43 and add and subtract it within the bracket. That's the next step. All of these steps have been explained already in completing the square video in our channel APS Education Math and Science videos. The next step is to take this one out of the bracket while multiplying this with this a outside. We have this a multiplied with this. Next step is to solve this. After we solve this, we would get 12.52. Then we would write down the final answer. So this is with a square, this is with a square. We have t. This negative sign comes from here. So we have t minus 1.43 to the power of whole square plus 12.52. And this is the equation that we have got in vertex form. Now the question wants us to find the maximum height. Maximum height is nothing but the k value. From this equation, we would get the vertex as 1.43, 12.52. Because this is the equation that represents height and time. So the y value we have is height, represented as lowercase in this particular question, and x value is time. As we know, the vertex first coordinate represent the value inside the bracket. So this would represent the time at which the maximum point or the k value or the height is going to be 12.52. So the vertex is 1.43, 12.52. So just in case the ball goes like this, the maximum height of the ball is 12.52. So this axes, y-axis represent height and x-axis represent time. Therefore, the height is 12.52 meters at time 1.43. Because time is given to us in seconds, therefore this is going to be 1.43 seconds. So this is how we read the answer for a given real life situation. Now when they say what is the maximum height, we would say maximum height is 12.52 meters. We are supposed to write on the answer to the nearest tenth, so just one decimal place. Therefore, we would write down the height is 12.5 meters. Next part of the question wants us to write down when does this occur, means when does this height occur. When means time. So at what time we would see the maximum height? That's a different way of saying the question. And we notice here that the time at which the maximum height is going to be 12.52 meters is 1.43 seconds. Therefore, when answer is time equal to 1.4 seconds, because we have to write on the final answer to the nearest tenth or one decimal place. So this completes our part A of the question. Next part of the question says, if a player on the other team contacts the ball at a height of 0.5 meters above the court, how long does it take for the ball to reach her? Now what does this mean is, if this is the path of the ball, we know the maximum height is 12.5 meters, as this represents height and this represents time, and this is 1.4 seconds. So there is a player in the other team who gets contact with the ball at the height of 0.5 meters. Let's say this is 0.5 meters. So the other player gets contact with the ball here before the ball actually hits the ground. How long does it take for the ball to reach her? So basically we just need the time, because how long means they want us to find out the time. So we are looking for what is going to be the time value when the height is 0.5 meters, because the equation that we are given is h equal to negative 4.9 t squared plus 14t plus 2.5. We are looking for time when height is 0.5 meters. All we have to do is just substitute height as 0.5 meters and solve for time. Now as we can see, this equation is in standard form and time we have is at two different spots. And whenever we are solving for a standard form equation variable, we need the other side to be equal to 0. So what we are going to do is move this number on the other side so that this side becomes 0. And we are left with negative 4.9t squared plus 14t plus 2.5 minus 0.5. And this gives us, this is the final equation that we have to work with in order to solve for t. Whenever we have to solve for standard form of equation that is equal to 0, we either have to do factorization or we have to use quadratic formula. In this particular example, we notice there is a decimal. Definitely factorization is going to be hard. So the best way to do is use quadratic formula. Quadratic formula is negative b plus minus square root b square minus 4ac divided by 2a. And we know here a is negative 4.9, b is 14, c is 2. We would just use all these ABC values to solve for the t value. Negative b means we have a negative 14 plus minus square root of 14 square minus 4a is negative 4.9. C is 2 divided by 2 times negative 4.9, and this would give us negative 14 plus minus inside the square root. When we put all of this on the calculator, we would get square root of 235.2. The whole thing divided by 9.8 with a negative sign. Then we get negative 14 plus minus 15.3 divided by negative 9.8. Since we have to solve two values, because one is with the plus operation and the other with minus operation, we would get negative 14 plus 15.3 whole thing divided by negative 9.8, which is equal to negative 0.136. And when we use negative 14 minus 15.3 divided by negative 9.8, we would get 2.989. Now we've got two values for time. Because this is an application problem, we always have to remember that time cannot be negative. Therefore, this answer is discarded. They want us to find out time when height of the ball is 0.5 meters. So that would be this answer, which we have to round to the nearest second. That means nearest whole number. So that would be 3 seconds. So the final answer to this problem is 3 seconds is the time that ball is going to take to come down to the height of 0.5 meters. Next part of the question says, if the ball would have fallen on the ground instead, after how many seconds would it have landed on the ground? So let's draw exactly what the situation is ball in. Because the ball has been thrown from Jenny, it goes up to the height of 12.5 meters. And now it says that the ball has fallen down to the ground. So because the initial or the launch height of the ball was 2.5 meters, as it is mentioned in the question, from the height of 2.5 meters above the court, Jenny serves the ball, and this ball reaches the maximum height of 12.5 meters, then it falls on the ground. They want us to find out how many seconds after it was served would it land on the ground. So again, we are looking for time when it lands on the ground. And we notice when the ball lands on the ground, the height of this ball, because this axis represent the height, so the height of this ball is 0. Now let's rewrite the equation that we are given. It's negative 4.9t squared plus 14t plus 2.5. Because we are supposed to find out the time when the height of the ball is 0, so we would substitute height as 0 and we would solve for t value. We know again this is a standard form of quadratic equation and the other side is equal to 0, so we would use quadratic formula to solve this. Quadratic formula is negative b plus minus square root of b squared minus 4ac, whole thing divided by 2a. Negative b is minus 14 plus minus square root of 14 square minus for A is negative 4.9, C is 2.5. Whole thing is divided by 2A, which is 2 times negative 4.9, and this would give us negative 14 plus minus square root of 245. The whole thing divided by negative 9.8. This gives us two answers. One is with a plus operation and one is with a minus operation. This would give us negative 14 plus 15.7 divided by negative 9.8, and this would give us negative 14 minus 15.7 divided by negative 9.8. Here we get a negative 0.17. And here we get a positive 3.03. Again, because we are looking for time and time cannot be negative, so we would rule this option out. So 3.03 is the time that the ball would take to fall to the ground or to land on the ground. And this is how we answer these type of questions whenever the application problems are given in the form of standard equation and they want us to find out the max or min. We use completing the square method to convert the standard form to vertex form in order to get the max or the min point. However, when the question wants us to solve for the unknown variable, that is the independent variable in the equation, in this case it is time, then we make sure that the other side is equal to 0. If it's not 0, then we move it on the side of the equation so that the other side becomes a 0. And once that happens, we would then apply the quadratic formula to solve for the unknown variable or the independent variable.